Alright guys, this is just a demonstration of the phenomenon of beats. Let's hope you can hear me clearly this time. So what I'm going to do is I'm going to play two frequencies. I'm going to produce two sounds, each of frequency 440 Hertz, and you can have a look at what that's going to sound like. So this is just one sound of frequency 440 Hertz. Alright, and this is when and now this is two sounds of frequency 440 Hertz. So I'm sure that you can hear that in this case you have a continuous sound. Okay, if both the frequencies are the same, you just get a continuous sound. In fact, you get a slightly louder sound. Okay, so when you superpose them, you get a slightly louder sound if you're playing two of them together. But now, if I change the frequency of one of them, let's see what we hear. Okay, so now it's 440 and 439 together. I hope you can hear that. So there's a loudness and a softness, right? There's a loudness and a softness, and this is taking place exactly for a second. The duration of each pulse, a loud, soft. That pulse is 1 second long. Because as we can see, when the frequency difference is 1 hertz, the beat frequency is 1 hertz. Beat frequency is the difference of the two frequencies. जितना ज़्यादा difference उतना ज़्यादा beat सुनाई देगा. Let's see if I make this 438 hertz. We expect to hear two beats. So instead of loud, 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 you'll hear loud, 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 loud. You'll hear two beats per second. So let's see that. One, two, one, two, one, two. So it's 1, 2, 1, 2, 1, 2. Hear that again. Yeah. I guess the demo was not a little clear earlier because this amplitude was not exactly the same. But when I make it exactly the same, you can hear it with clarity. Alright. If I make this frequency, in fact, let me just show you again how the first one looked with the correct amplitude. Yeah. 1, 1, 1, 1. Fair enough. Similarly, as we continue to increase the frequency difference, right? So 440 to 437. So you continue to increase the frequency difference, the number of beats also increases. So this will have, the difference is 3 this time, there will be 3 beats per second. So it will be like 1 2 3 1 2 3 1 2 3 1 2 3. Let's hear that. 1 2 3 1 2 3 1 2 3 1 2 3. How about 4? So that's like 1 2 3 4 1 2 3 4 1 2 3 4 1 2 3 4. Okay, it's getting faster and faster. It's all getting fitted into that 1 second. I'm snapping my finger every 1 second. So 1 2 3 4, 1 2 3 4, and so on and so forth. You can keep going. Of course, there will come a point where um, there will be so many beats that, I mean, the beats will be so quick that our ears will not be able to tell the difference. So because the ears have the limitation, and two beats very close to each other will start to sound as one because of the persistence of sound. Two beats very close to each other will start to sound as one. Therefore, after a point, it will become a little unclear. But can we hear five beats? Let's check. 1 2 3 4 5, 1 2 3 4 5, 1 2 3 4 5, 1 2 3 4 5. I think that was still quite clear. 1 2 3 4 5, 1 2 3 4 5. Can we hear six beats? I guess this should be 1 2 3 1 2 3 1 2 3 1 2 3. Let's hear that. 1 2 3 1 2 3 1 2 3 1 2 3 1 2 3 1 2 3 1 2 3 1 2 3 1 2 3 4 5 6 1 2 3 4 5 6 1 2 3 4 5 6 1 2 3 4 5 6. Yeah, 1 2 3 4 5 6 1 2 3 4 5 6. That could be heard. 7, I think after the point becomes too quick. 1 2 3 4 5 6 7 1 2 3 4 5 6 7 1 2 3 4 5 6 7. Yeah, maybe that's a little too quick for you guys to count, but um, that's still 7 beats per second. So musicians will actually be able to tell that 7 beats per second. Maybe this is a little bit more common to the ears. 8 beats per second. 1 2 3 4 5 6 7 1 2 3 4. Yeah, so it's quite fast to call it out, but you can still almost count 8 beats. But after a point, then as you probably can see by now, that after a point it gets a little too fast. So I'll just continue showing that. This is 11 beats, 12 beats, 13 beats, 14 beats. I'm not sure if you can tell, but I think it's starting to become a little clear that the frequency is gradually decreasing. The overall sound that you're hearing is sounding lower and lower, and that's because, as I mentioned earlier, the frequency, the pitch that you hear is actually the average of these two. So the pitch that you're hearing in this case is the average of 440 and 426, which is 433 hertz. So the pitch you're hearing is continuously decreasing as I keep reducing one of these sounds. Okay, so in the final demonstration, I'm going to go down from 440, okay, as low as we can go. Notice both things. Notice how the beat frequency increases as the difference between the two increases, and notice how the pitch, the average pitch, if your ears can tell, your average pitch is also decreasing as I'm going to reduce the frequency of the second one. Let's just hear that once. One beat, two beats, three beats, four beats. Sorry. Sorry. Messed up. See, that was the original pitch, and this is them together. Okay, so visibly, when the two are together, the pitch is definitely lower than 440 hertz. Alright, I hope you guys now, at least with this, you've seen an example of how beats works, how it takes place, and of course, we'll explore the maths behind this in our regular classroom hours. Bye. Have a nice day.